The topic for today is types of chemical formula. Types of chemical formula is like a chemical formula. We knew it tells us how atoms combine in a compound, no? But there are two ways we can express them. One is empirical formula, the other one is molecular formula. It's like the simplify, say, if I take a body, human body, okay, this is right, and this is the skeleton, okay. Empirical formula is just like the skeleton of a human body, and molecular formula is just like the body of the human. What I meant is molecular formula shows actual number of atoms present in one molecule, which means they are the real formula of a compound. But when it comes to empirical formula, it doesn't show the actual number of atoms, but instead, right, it is only showing the simplest ratio. For example, if I take H2O2 and C2H6, the empirical formula for H2O2 is HO, CH3. But when it comes to molecular formula, this is the molecular formula. Molecular formula, and this is the real formula. This H2O2 and C2H6. We have created a relationship between these two, okay, the empirical formula and molecular formula, and we simply call it as EM relationship, or you can remember like English medium relationships. Molecular formula is equals to empirical formula into N. N is equals to molecular mass over empirical formula mass. Okay, these two equations will be useful when you come across questions. Simply, like it's just like a shortcut or something. Now this is an example. Okay, if of a certain compound, this is the empirical formula. Now we have to find the molecular formula. Right? To find the molecular formula, we can use either equation. Okay, so I'm gonna find the empirical formula mass. We know carbon is 12, hydrogen is 1, so 12 plus 1 into 2 is equals to 14, right? The empirical formula mass is 14. The actual molecular mass is already given for us in the question. The molecular mass given as 28. This is given. If we are asked to find the molecular formula, we knew the molecular mass, we knew the empirical formula mass, we can find N, right? So N is equals to molecular mass 28 divided by the empirical formula mass 14, so we get 2. Now we have found N. Can't we find the molecular formula? Using this equation. Right here I have used this equation. Now the next step is molecular formula is equals to empirical formula. Empirical formula we already know, right? It's given in the question. CH2 into what is N? Just now we found, that is 2. So molecular formula of this compound is C2H4. Remember this trick, very easy trick to easily identify the molecular formula. There's something very important we have to learn. We have 4 steps to determine empirical formula. You can use this step also to identify the empirical formula, and from the empirical formula you can find the molecular formula. Now the first step is you have to get the mass of element in grams. The second step is Divide by respective atomic mass to get moles. Atomic masses to get moles. The third step is divide all mole values by the smallest number of moles to get simplest ratio. The fourth step is, if not whole number, right, you have to multiply by a factor to get whole numbers. Okay, now I know you all don't understand what I have written over here, and now to this very step, if you do, you can get the empirical formula. Once you get the empirical formula, you have to convert that empirical formula into molecular formula. So for that, you have 3 steps. First step is calculate empirical formula mass. Second one is divide, N is equals to molecular mass or empirical formula mass. And then third one is the molecular formula. You have to take the empirical formula multiplied by N. These are the 4 steps to find the empirical formula. And from the empirical formula, you have to do 3 steps to form the molecular formula. Now let me take an example to clarify this. Here the question says to identify the molecular formula. And in this, they have given the elemental percentages of chlorine, carbon, and hydrogen. 71.65%, 24.27%, 4.07%, and also the molar mass of the compound is given, that is 98 grams per mole. Now, as I already told, the first step, it is here. Let me go on. As I already told, the first step is here. We have to get the mass of element in grams. So when they say mass percentages, it's like this. Now, if I take this entire compound, right, in 100 gram, right, in 100 gram of the compound, in 100 gram of compound, if I take chlorine is 71.65 grams. Okay. If I take carbon, it is 24.27 grams. If I take hydrogen, it is 4.07 grams. The second step here is divide by the respective atomic masses to get moles. So the atomic mass of chlorine is 35.5, carbon is 12, and hydrogen is 1. So if I divide this by 35.5, I get 2.043 moles. And if I divide this by 12, I get 2.022 moles. And if I divide this by 1, I get 4.07 mole. Now the third step is divide all mole values by the simplest number of moles to get simplest ratio. So out of these 3, see here, the simplest mole value is for carbon. So we have to divide what it said in the rule, divide all the mole values by the simplest number of moles to get simplest ratio. So the simplest one, in the sense, we have to pick for that one. This is the simplest one. So we have to divide all by the simplest one. If I take this, 2.043 divided by 2.022, and this 2.022 divided by 2.022, right? If the same numbers are divided, it is 1. Here it is 1.01, and here 4.07 divided by 2.022 is 2.01. And the fourth rule says, if not whole number, multiply by factor to get the whole number. But here, we can assume this as 1, this is also 1, and this is 2. So if we write the formula, empirical formula, it will be, here this is carbon is 1, C, hydrogen is 2, H2, chlorine is 1, CH2, Ca. Now you have to identify the empirical formula mass. Here, the empirical formula mass empirical formula mass is equals to carbon is 12, hydrogen 1, chlorine is 35.5, which means 12 into 1 plus 1 into 2 plus 35.5 into 1. So we get 49 grams per mole. The molar mass is given for us in the question itself. So we have to take the molecular formula mass and divide it by empirical formula mass, or you can also say molecular mass for this. Molecular mass is given as 98 grams per mole divided by 49 grams per mole is equals to the number of moles, no? That is 2. To identify the molecular formula, remember this method is same as here. Okay, molecular formula is equals to empirical formula into number of moles. That means number of moles we found, it is 2. Here the empirical formula is here CH2Cl into 2. The molecular formula mass is C2H4 and Cl2. C into 2 C2, 2 into 2 4, Cl2. That's how we identified. And this is the step to identify the molecular formula for word problems, or else you can use EM relationship. So consider this as method 1 and this as method 2. The EM relationship is a shortcut or whatever it is. And one more thing under this, that is the next topic, mass percentage of A is equals to moles of A into atomic mass of A divided by the molar mass of compound into 100. Sorry. Now for this, I have an example to show you. This is one of the equations you have to remember. Now the question is calculate the mass percentage of oxygen in H2O2. Then what you have to do is you have to find the molar mass of compound. So what is this compound? H2O2. So molar mass of H2O2 is 2 here. Hydrogen is 1, oxygen is 16. So 1 into 2 plus 16 into how many oxygens are there? 2 is equals to 34 grams per mole. The next step is you have to find how many moles are there. Moles of oxygen. So how many moles of oxygen are there? 2 moles. And then next step is mass of oxygen. Now moles of oxygen done, right? The third step is mass. Mass of oxygen is equals to, it's like this now, N is equals to M over M, which means this is the mass over molar mass. Now I know this and this. Can't I find the mass? Can. So if I multiply this, you can find the mass. So mass of oxygen is equals to N into molar mass. N is 2 into, what is the molar mass of oxygen, not the compound. Right? This is the molar mass of the compound. I'm asking the molar mass of oxygen, that is 16. So we get 32. Now the mass percentage of oxygen. Okay, the mass percentage of oxygen is 32 divided by 34 into 100, which is equals to 94.1 percentage. Or else you could have started from this also. According to the equation, it is like this. It goes from this step. 2 into 16, the moles and atomic mass of mole of oxygen, atomic mass of oxygen, divided by the molar mass of the compound into 100. What you will get same answer, 94.1%.